Hello and welcome. We're going to do the USACO 2019 February contest bronze problem 1, sleepy cow herding. I will assume you have read the problem, so we're just going to jump into the algorithm. So you see that it first asks what is the minimum, so let's calculate that. We have three cases. Case 1 is there's no gap. All consecutive numbers. For example, 1, 2, 3, 4, 5, 6, 100, 101, 102. Those are consecutive numbers. So there is 0 moves you have to account for. Case 2 is a little more complicated. It's a gap of 1. So what do I mean by this? Gap of 1 is like this. You have any number a, oops, a plus 1 or 2, and then you have some random number b. So you have this sequence. So what are you going to do? Of course, you're going to put the b right here. So it becomes a, a plus 1 and a plus 2. So that's essentially how case 2 works in the minimum. So finally, we have one more case, is all else, everything else. 2 moves. It's really easy. So if you have numbers a, okay, it's so bad. Sorry. A, B, and C, what can you do? You can obviously put the C as close to the A as possible by 1 plus 1. So after that, you'll get A, A plus 2, D. So then you just move this. So that's 2 moves. And that's our last and final case. So now let's move on to the maximum. Maximum is a tiny bit more complicated. If you have numbers A, B, and C, and you want to find the maximum, what you're going to do is you're first going to calculate what is this. It looks complicated, but it's actually easy when you look at it in the right way. So you move the A, sorry. When you move the A as closest to the B as possible, you get this. And then you're going to leapfrog. So this is going to go right here. B is going to go in front of A is going to go in front of B is going to go in front of A is going to go in front of B, all the way to C. So you're leapfrogging here. It's complicated. Well, not that complicated, though, when you look at it in the right way. So what is this? This is C minus B minus 1. That's the gap, essentially. And now it's the same here, but instead you move the C to the B as close as possible and then leapfrog here. So this should be B minus A minus 1. So then the answer will just be the max of this. The max of B minus A minus 1, C minus B minus 1. Okay, so let's jump into the code since we have the algorithm down. Okay, so here you see the code. What we're gonna do first is, oops, test. Okay, so you see in the code, we're first gonna include our headers. We're gonna have to use algorithm, IOStream, and vector. and we're going to include our using namespace SDT. Now we have our main function. We're going to include our file input and output here using reopen, file reopen, and we're going to have a vector named cows. These are going to be the 3 cows we inputted using this variable b and pushback. So now we're going to use our sort method in algorithm, and we're going to sort from the beginning of cows to the end of cows. Okay, so this is where our casework for the minimum starts. So if they're all consecutive, then we just see out 0. Else, if there's one gap, then we see out 1. Anything else, see out 2. And then we account for the maximum. So that's going to be our case of comparing the gaps. So it's going to be this right here. And we're going to return 0 to exit the program at the end. Take a quick look. It's not that complicated. Maybe take a screenshot if you need it. Okay, we're back at the USACO website, and let me take some time to sign in. Going back, I'm going to submit. Let me choose the file. Okay, I chose the file and I'm going to submit it. Okay, we are done, and that was 2 milliseconds for each case. If you use Python, it might be 4 milliseconds, but I didn't really use anything very language specific, so it'll be pretty easy to convert from C++ to any other language you use. So that was the end of the video. USACO 2019 February contest bronze, problem number 1, sleepy cow herding. Hope you enjoyed, and bye.